Welcome to CKA Cert Hands-On channel. The purpose of my channel is to get people who want to give CKA 2025 exam get started on their hands-on practicing journey once they finish the formal course of CKA and have a basic understanding of Kubernetes concepts. This creates a depth in your understanding of each concept and helps you crack CKA exam. CKA exam consists of questions from 5 different categories. As you can see here, we are currently in troubleshooting category that has 30% weightage in CKA exam. I have a playlist for each category of CKA exam. Please do check out my playlist for networking and storage categories that carries 20% and 10% weightage. The links for the playlist are provided in every video. So I just want to, before getting started with solving today's problem, I want to spend some time on the allocation and the concepts here. Right now, what we are going to watch or try to understand is about network policy. And if you see here, the define and enforce network policies, it comes under servicing and networking, but we are dealing with it in troubleshooting category. So it doesn't matter because we do troubleshoot services and networks. If you understand the concepts in services and networks, then it kind of, you have that knowledge to troubleshoot that particular domain, right? So try to get all these concepts, try to get a solid understanding of these concepts. Go to the documentation, Kubernetes documentation, read it. If you don't understand it, read it again. Try solving problems like the labs that we are doing as much as possible. It's only when you try to solve the problems, then you will understand where are the gaps in your knowledge, and then you will go back to the documentation to understand. That's how you'll get a complete understanding. And so let's go to network policy to understand. So network policies are to control the traffic flow at the IP address or port level. They allow you to specify rules for traffic flow within your cluster and also between pods and the outside world. Now your cluster must use a networking plugin that supports the network policy enforcement. So if you don't have a networking solution that doesn't have a network plugin that supports the network policy enforcement, even if you define network policy, then it will not be of any use, because I think that's what it says, implemented by the network plugin. So to use network policies, you must be using a networking solution which supports network policy. Creating a network policy resource without a controller that implements will have no effect. If you go to, I want to explain it using an example here. So typically you will have your API version, your kind and metadata, and then you'll have your spec and then the port selector. This port selector refers to the set of ports that you are targeting. That's the network policy gets applied onto these ports. So here, that is what the port selector does. So if you see here, it refers to the ports which have the label role is DB. And then you have policy types which are ingress and egress. Ingress is for your traffic flow to the pod, and egress is for the traffic flow from the pod. So, and you can have different types of policies, and they both in ingress and egress, and they are, how do you want to target the traffic, whether it is an IP block based, or it is a namespace based, or it is a pod selector based. Then you can have, based on the type that of your requirement, you will specify that specification in your from section in ingress and in to section in egress. So what it basically says is, if you try to understand this network policy, it is enforced on the pods that have the label role equal to DP, and it has two policy types, both ingress and egress. So what it does is it allows traffic from all the IP blocks containing all the IPs within this CIDR block range except this particular range. It also allows the traffic from this selector from the namespace from all the resources from namespace called project, which has a label called project equal to my project. And it also allows from role equal to, this is the pod selector, from the set of the pods. So all the pods that have label role front end can send the traffic to this pod which has role DB, and it will not be blocked. And the outgoing traffic from this pod selector which has the label role DB, it will only be targeted against this IP block and this particular port. So that is your basic understanding. And now let's go back and try to solve this question. We'll set the context. It says red pod, green pod, blue pod pods are running, and red pod exposed within the cluster using red service and network policy applied on red pod. Problem is now the red pod is accessible from both green pod and blue pod. Fix the issue that green pod only can be able to access red pod port. So we have 3 pods here. So if you see get pods, all of them are running, and k get services. So we've got this red pod is exposed using red service, and there is a network policy that is applied on red pod. So let's try to describe the red pod and see if there's anything about the network policy that we can see here. I can't see any network policies here. Okay, let's get network policy and see what is this. So there is a network policy, and if you can see that it is run equal to red pod, and if you see our labels for the red pod, the label is actually run equal to red pod. So this is the network policy. Allow green and blue is the network policy that is enforced on the pod selector run equal to red pod. So we can describe this network policy. And it is actually already run equal to green pod. Okay, so let's try to restart the lab. Yeah, so let's try to restart the lab again. Get network policy. It's the same thing. I'll just describe it again. Yeah, so if you see here, run equal to green pod, run equal to blue pod. The reason why it was just showing the green pod before is I probably was accessing the lab that was already solved. So that's why you could only see green pod. I've restarted the lab now. So now you can see that the network policy has the ingress traffic from both port selectors run equal to green pod and run equal to blue pod. Now they're saying the problem is now the red pod is accessible from both green pod and blue pod pods. Fix that issue so that the green pod can only be accessible from red pod. Okay, so what you need to do is edit network policy and allow green and blue, which is the name of the policy. And if you go, as I have explained before, because it is in Gress, it says green and blue, but we need it to have just green. So we'll select the rules, we'll remove the rules for blue pod and save. Now if you describe the network policy, you can see that it allows ingress traffic only from port selector run equal to green pod. Now if you I think that should fix it. Let's try to check the solution. So yeah, the validation is successful. So that is how we troubleshoot network policies. It will be easy if you try to understand what network policies are used for and what are the specifications that are there in the spec of the manifest of a network policy. You will be able to solve the question in a much faster fashion rather than just learning the syntax of the manifest files. So that is it. I will post the KillerCoda link and also the documentation link in this video. Please, if you think my videos are helpful, do subscribe to my channel and also like and share my videos. I will be providing the links for all of the videos and all of the playlist videos so that you can refer to other domains and concepts. If you need any particular video about any specific domain, please let me know. I will work on it and post it soon. Thank you. I'll see you in the next lab. Keep learning. Bye.